that we're starting today is on polynomials. Notice here it says algebra, arithmetic, and polynomials and rational expressions. So pretty much it's to understand polynomials. Today we're going to introduce them and get to know them a little bit better, okay? However, I still asked you to remember that we're still trying to target this standard, the Math Practice Standard 6, which is what? Attend to precision. Remember that? So you got to be precise when you mark your steps, give me an answer, and elaborate on whatever you're thinking. Okay, here we go. So our objective for today, I can classify and evaluate polynomials according to degree and number of terms. Let's read it together. 1, 2, 3. I can classify and evaluate polynomials according to degree and number of terms. So, and if you notice, today we start with a new concept. So think about it. What is the concept for today? Think about it. Okay, tell your neighbor the concept for today. Polynomials. Like I said, from this point forward, you're going to be turning the corner over there to go to Donut Avenue. All of a sudden, dun, 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 polynomials. Yeah, they're going to be everywhere. Yeah. All right, here we go. I'll show you guys how it applies to different things over there. All right, so with that said, you wrote your objective at the bottom left, right? Okay. So, before I get started, on the left-hand side of the Q column, does everybody see how you have a lot of space there? At the top, I want you to write a monomial on the Q column, top left. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. A monomial is a number, comma, a variable, comma, or a product of numbers and variables with whole number exponents. And it says here, a monomial may be a constant or a single variable. And I'll show you that right now. Copy that, please. All right, here we go. Pens down, eyes up here. It says, a monomial is a number, comma, a variable, or a product, which means multiplication of numbers and variables. However, they're being specific with the exponents. Is a whole number exponents. What are whole numbers? 0, 1, 2, 3, 4. So does it include any negatives? No, right? Let me give you examples of monomials. Pay attention, please. You're just paying attention. Here he goes. So, look at this. It says, a monomial is a number. Here's a 5. Okay, yeah, that's a monomial. A variable. Do we have a variable here? Yes. A product of numbers and variables. Do we have multiplication here with numbers and variables? Yes. And also that include whole number exponents. Here's numbers and variables multiplying, and then it has an exponent of 4. Is that a whole number? Yes. Let me show you what it's not. What a monomial is not. Pay attention, please. Look at this. We have numbers and variables multiplying, but look at the exponent. What is this? A -2. That is not a whole number. Look at this one. Here they're multiplying, but what is going on between this variable and this variable? Subtraction. But what is the only thing that it needs to do? Multiply, which is a product. But you're saying, look at this one. This is a whole number. That was before it went to the denominator. What was it before it came to the denominator? -3. That's why these are non-examples. Copy these, please. Right there underneath your definition on the Q side. Any questions with monomials? We got it, right? All right, so let's clarify now what the main concept for today is. The main concept for today is polynomials. So, yeah, so here we go. On your Frayer model, you write polynomials, definition, monomial, or sum of or difference of monomials. Fairly simple. Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Okay, examples. 2 is a monomial. It's also known as a polynomial. X squared, also known as a polynomial. Negative 3x to the fourth plus 2 is a polynomial. And x squared minus 3x plus 2 is also a polynomial. Copy those. Guys, up here. Here we go. So, polynomials. Monomials, or sum or difference of monomials. So it says it could be a monomial, or it could be two monomials being added, or three monomials being added, or many monomials being added or subtracted. Is that correct? That's what the definition says. So let's see. Is 2 a monomial? Yes, so that's a polynomial. Is x squared a monomial? Yes, so that's a polynomial. Look at this one. Negative 3x to the fourth is a monomial. 2 is a monomial. And what's happening in between? Add, so therefore it is a polynomial because it says here the sum, right? Look at this one. Monomial, monomial, monomial. What's going on? Subtraction and addition, so therefore this is also a polynomial. Very simple. Okay, now before I move on, I want to clarify because I like to know exactly what I'm reading. Even though you've heard the word monomial and polynomial before, I want to clarify this. The word monomial has two parts. Mono means one. Nomial means part. Or, focus please. Mono means one. Nomial means part or term. So what does the word monomial mean? One part or one term. Does that make sense? Okay, so check this out. So by looking at this, this one has one term. That's why it's known as a monomial. One part. Okay? Hold on. So is this one a monomial? Are we there? But this one has two parts. Now, if you have a motorcycle that has 4 wheels, what is that called? Quad, because there's 4. When you were a little kid, you started with, instead of the bicycle, you started with a tricycle because it had how many wheels? 3. So think about it. How many parts, everybody look up, how many parts does this one have? 1, 2, 3. So if it's 3 parts, it's a what? Trinomial. You're like, that's why it's called that. Yes, that's why it's called that. Trinomial. So therefore, if this one has 2 parts, this one's called a binomial. But all of them together, they're called what? Polynomial. Why poly? Because the word poly, everybody look up. Poly means many. And we already know what nomials mean, right? Terms or parts, right? Okay, write that in there, please, so you remember. All right, here we go. So we understand what a monomial is, binomial, trinomial, and polynomial. Are we there? So now let me give you another example. Check this out. Look at these. Write these down. We have 2 equals 2x. This one, x squared plus 3x plus 2 equals 0, and negative 3 plus x equals equals 10. As you're writing them down, think about it. If these are examples of polynomials, why aren't these? Why aren't these? It looks pretty obvious for some of us. For some of us, it's not. But if it is, talk it over with neighbor. Why are these not polynomials? Okay. Pretty good. I heard some people say because Mr. Q said so. I like that. Very good. But also, I saw some of you say that these are equations and these are expressions. So therefore, polynomials, critical attributes is that they are what? Expressions only. Expressions only, and they have various terms. Various terms. Expressions only, various terms. Expressions only, various terms. Okay? So check this out. So to get started, there's 4 basic steps that we're going to be working on, and it's a lot of writing. So I'm going to leave that up to you to write. So which means, check this out. By the end of the lesson, you're going to understand the process, and you can write your own steps. Or, number 2, you can go to YouTube. I'm going to upload the video. Look at the steps, write them down. You don't have to watch the entire video if you're comfortable with what you did already. And just write down the steps. Everybody with me? Okay. Turn your paper over, please. We're going to continue in the back. So you can leave space underneath for steps. And these are the steps. It's 4 basic steps. Like I said, leave that space under the prayer model for that. You can do that on your own. Okay, so turn your paper over. We're going to continue in the back. So, really quick, we know what monomials are. Are we there so far? Okay, but what we're going to do right now, we're going to identify degree of monomials. So pens down, eyes up here. Focus, please. Degree of monomials. Degree of monomials we find by finding the sum of the exponents on the variables. To find the degree of a monomial, we just find the sum of the exponents of the variable. What does the word sum mean? Addition. So we're going to add what? The exponents on the variable. So check this out. You're just paying attention to this. This is a monomial. Right? Okay, and by looking at it, it has how many variables? 2. And I'm going to look at the exponents on the variables. This one is 1, and this one is 1. To find the degree, it says what? Add the exponents of the variable. So what is 1 plus 1? So this is to the degree 2. Are we there so far? Okay, look at this one. How many variables do you see? 1. And what is the exponent? So this is the degree of 4. Some of you are saying, Mr. Q, do we have to put a 1 on the 7 and the 5? No, because we're not adding the degrees of the numbers, are we? I mean the exponents. Only the ones on the variable. So check this out. Look at this one. What is the exponent? So the degree is 1. Look at this one. Does this one have a variable? No, if it doesn't have a variable, the degree is 0. Are we there so far? Okay, think about this one. You don't have to copy this. Just think about it. If I gave you the monomial negative 4x to the third, y to the second, and z to the 18. Think about it. Don't say it out loud. What would be the degree of this monomial? Okay. Who thought 23? Michael Jordan, right? Because what are we doing? We're adding the exponents on the variable. Am I adding the exponent on the 4 to all this? No, just of the variables. Are we there? All right, so copy example number 1, please. Copy this one. Example 1 says, find the degree of each monomial. Example 1, find the degree of each monomial. Example 1, find the degree of each monomial. Yeah, you just write degree equals, and then just the number that it is. So A is 4p to the 4th cubed. B, 7eb, and C, 3. Find the degree of all those 3. Don't worry about this. These are just the steps. I'm going to show you the process as we go along to see if you memorize. Let's see. For this one, this is a monomial. Okay, I'm looking at it, and my degree is equal to 7. Hands if you got that. Okay. This is a monomial. The degree is equal to 2. Hands if you got that. Okay, how do we get that? We look at the variables, the exponents. 1 plus 1 is 2. This one was 4 plus 3, that's 7. This is a monomial. The degree is 0. Hands if you got that. Okay, why 0? Because it doesn't have a variable. Are we there so far? Okay, do these next one by yourself, please. You should be getting these by yourself easy. Here we go. Example 1, D, E, and F. You don't have to find the degree. You already wrote it, right? But just write these down and find me the degree. Go. Share with a neighbor your answer. See what they got for those three. Okay, let's see. This one is 3. This one is 1, and this one is 3. Hands if you got all 3. Okay, pretty good, right? All right, fairly simple. So, look at the step 1 of the note. Step 1 says, identify the degree of each term of the polynomial. Right now I showed you how to find the degree of a monomial. Now let me show you how to find the degree of a polynomial. Here you go. For this next part, pens down, writing utensils down, eyes up here. Okay, focus please. Here we go. First things first, they give me a polynomial and it says, write the polynomial in standard form, then give the leading coefficient. I'll tell you all those pieces once I do the first step. First step, we know how to identify the degree of monomials, don't we? So check this out. I'm going to circle the first monomial. If we look up there, first monomial is 6x. What is the degree on that one? 1. Okay, so I got that one. I circle the next monomial, or the next part, and what is the degree on that one? 5. Focus please guys, or you're going to be lost after this point. What is the degree of this next one? 2. And the last piece, what is the degree of that one? 0. So, now that we know how to do that, to write it in standard form, what that is writing it from the highest degree to the lowest degree, rewriting it. That's all it is. That's called standard form. So check this out. What is the highest degree of all these terms? This one right here, right? So then I write negative 7x to the 5th. That's my first term that I write, because I'm writing it from highest to lowest. What would be the next one up? 2, which is positive 4x squared. Are we there so far? The next one up would be what? 1, which is what? Positive 6x. And what would be the smallest degree? This one, which is plus 9. This is called standard form. Are we there so far? And the last piece, they're asking you, okay, first of all, write the polynomial in standard form. Did I do that? Yes. Next, then give the leading coefficient. The leading coefficient, I'm going to write LC. Leading coefficient, first of all, what is a coefficient? A coefficient is a number that multiplies a variable. So check this out. What number is multiplying this variable? The 6, that's a coefficient. What number is multiplying the variable here? The 4. What number is multiplying the variable here? Negative 7. Those are coefficients. The leading coefficient is the first one, once you write in standard form, the first one from left to right. So look at these. Out of these coefficients, which one's the first one from left to right? Negative 7. And we're done. They're asking us to do 2 things. Standard form, we got this. And the leading coefficient, we got this. Copy that, please. You don't add any of the other leading coefficients? No, we don't. We just identify the leading coefficient. Okay? All right, so just to double check my steps. This one says, write the polynomial in standard form, then give the leading coefficient. So what is the first step that we do when they give us a polynomial? Identify the degree of each term. Step 1, identify the degree of each term. Step 1, identify the degree of each term. Step 1, identify the degree of each term. Step 2, arrange it from greatest to lowest degree. Arrange it from greatest to lowest degree. Arrange it from greatest to lowest degree. What is that called? Standard form. And then at the end, you just identify the leading coefficient. Everybody got it? Okay, let's do another one and see if we can do this one together. Here we go. For this one, you don't have to copy all the black text. Just go example 2b. Copy this polynomial, please, and let's do this together. We're going to write it in standard form. and identify the leading coefficient. Yes? Okay, here we go. So everybody write example 2b, y squared plus y to the 6 minus 3y. Everybody ready? All right, here we go. I'm going to start with red. Circle your first term. What is the degree of that one? 2. Next, I'm going to green. Circle the second term. What is the degree of that one? 6. And then in blue, I'm going to circle the last term. What is the degree of that one? 1, because the exponent of the y is a 1. So now that we identified the degrees, now we write it in standard form, okay? Turn to your neighbor, let them know what would be the first term you write. Y to the 6, very good, that's our first term. What would be our second term? Y to the second power, and what is the sign? Positive, okay? And what is our last one? Negative 3y. So now this is called what? Standard form, from greatest to least degree. And let's identify the leading coefficient. So check this out. What number is multiplying the y right here? Everybody look up. Right here. Negative 3. How about this one? 1, an invisible 1. How about here? 1, an invisible 1. So what is our leading coefficient? 1. I said the leading coefficient is the number that multiplies the variable from left to right. Do you see there's a 1 here? So from now on, whenever you have a variable without a number multiplying it, we already know that it's what number? 1. Are we there? Okay, yes. Then it wouldn't be here, right? Because that's not a polynomial because it goes to the denominator. Remember that? Let's do another one. Let's see if you can do this one by yourself. Copy that. Example 2c, 16 minus 4x squared plus x to the 5th and 9x to the 3rd. Go. So let's see. Let's see, I'm going to rewrite it. I'm going to skip the step where I circle stuff to see if you got this the standard form right. Who wrote x to the 5th plus 9x cubed minus 4x squared plus 16? Hands if you got that. Okay? And for the leading coefficient, who got 1? Because the leading coefficient is the first one from left to right in standard form. Are we there? It's not the 9, it's not the negative 4, and it's not the 16. We go with the first term, first variable, and the number that's multiplying. Are we there? Okay, yes. If it's only a variable, you just put 1. Simple as that. What if it was this? Everybody look up. What if instead of just this, it had a negative in front of it? What would be the leading coefficient? Negative 1. Does that make sense? All right, so check this out. Let's do one more. See if for this one, everybody look up. Example 2D, write the polynomial. Skip the step where you circle stuff. See if you can go straight to writing it in standard form. Go. All right, let's see how we did. See how we did. Okay, I said, for this one, let's see if we can skip the step where you circle each term and just write it in standard form. By looking at it, let's see. The first one, or the highest degree, is this one, so you should have written negative 3y to the 8th. The second term after that is this one, so it's plus 18y to the 5th. And the last one is plus 14y. Hands if you got that. Okay? And by looking at it, the leading coefficient, if we read it from left to right, is negative 3. Hands if you got that. Okay? Questions, comments, autographs? We're good? All right. So far, so good, right? Okay, so, yes. The variable, yeah. Okay, yes. To get the leading coefficient, everybody look up, please. Now that I have it in standard form, once again, you read it from left to right. From this side that way, and the first number multiplying the first variable that you see. In this case, it was a -3. Previously, it was, for example, if it's a negative, then this is a -1. This one, if it was just a variable, then it's 1. Everybody see that? Okay, now we go to this next piece. Pens down, please, eyes up here. Now, there's such a thing called classification. Classification, which means naming a polynomial. Now, there's two ways of doing it, by degree and by the number of terms. Now that we know that there are names for terms like monomial, binomial, trinomial, and polynomial. Are we there? But there's also names for polynomials according to degree. Constant, linear, quadratic, cubic, quartic, quintic, and from there on it's just to the 6th power, to the 7th power, to the 8th, and so on and so forth. So for homework, you have to name some polynomials. For example, everybody pay attention here. If I gave you this one, x squared plus 5x plus 6. I'm going to give you this as you walk out. You're going to grab one on your way out. So check this out. And you've got this polynomial. Pay attention, please. First of all, you're paying attention right now. You need to identify the degree of each term. This one is 2, this one is 1, and this one is 0. What's the highest degree? 2. So then you circle here the 2 because that's the highest degree. Are we there?
Yes.
How many terms does this have? 3. So you look for the number of terms, which is this one. So this one could be written here. X squared plus 5x plus 6. And the name of this one is called a quadratic trinomial. Everybody see how that works? Okay. Also, there's going to be one word problem in the homework, so just go through it, and all you have to do is substitute. But your homework will be out of page, what? 433, numbers
1 to 43.
1 to 43 odd. Turning your homework on your way out. Grab one of those sheets. Turn them in. Have a good one, guys. Enjoy your homework. See you guys tomorrow. Or tonight. And also, we are going to have tutoring today. Make sure if you're going to be here for tutoring, be on time. Bring your snack. Share with me. Have a good one. See you later.